In this session, we'll be adding a PID loop to the Talon SRX. We'll go to the robot.h file and enter in a new variable called elevator position. This will be the feedback from the encoder for the elevator motor that we created in the last exercise. Next, we open the CPP file. We're going to take the elevator position that we've read and print it out in the robot periodic function. There it is right there. We have nothing to do in autonomous init or periodic or autonomous periodic for this task. The teleop task is going to change significantly. This code right here is what I just added. Let's just walk through this. The elevator motor, which we created in the previous exercise, is right here. We're going to set it to the default factory configuration. Then we're going to configure a quadrature encoder as the sensor. This is the same type of Grahale encoder that we've talked about before. It's connected on the 5-pin header straight to the mock Talon SRX board. It's mounted on top of the Talon SRX. That will be the feedback element. It's configured with this line right here. One issue that you may have to correct for when you physically build this is making sure that the sensor phase is correct and the inversion is correct, depending on how you built your robot and how it's wired up. For the exercise that I have on the tabletop, it doesn't really matter which way it's going because it's not a real elevator. It's just a motor and a quadrature encoder. This is some housekeeping stuff. We'll get to this in a later session. Same thing here. This is the P, the I, and the D that you use in a PID loop. You can tune these parameters to optimize how the elevator is moving around. This has to do with maximum velocities and accelerations. You can tune these parameters and play around with these to see what it does. For now, when we start up, when we do the init, we're going to reset the position sensor count to 0. In an elevator application, you'd do something more sophisticated and making sure the machine's at the bottom. There's actually a way for when it hits the limit switch to do this automatically. For now, we're just going to start with a 0. But this is a one-time configuration when you go into the teleop mode. And you'll see the cool stuff next. In the teleop periodic mode, we have all of these getters. I'm going to add one more. I'll put it right after the yaw. This will read the sensor position from the Talon SRX controller and store that value in elevator position. We will print this to the shuffleboard using the robot periodic task, the statement that's up there. We're getting a little goofy with our code here. We have our 4 buttons on the Xbox controller that we're using to set the rotate values on the NavX board. I'm also going to just use the same buttons to create set points for the elevator. So if you were to actually run a robot doing this, it would actually be turning and twisting and going up and down and acting pretty funky. So if you hit the Y button, it's going to set a set point on the yaw controller. It's also going to set a set point on the position controller. It's actually configuring two PIDs at once. It's a little bit wild. Since this is a setter, I'm going to move it down here to where we're setting all this other stuff. Now let's not make a rookie mistake. We just put a PID on the elevator motor, and now the PID is controlling the motor. We still have this line from our previous project. The rookie mistake would be to leave that line there, so we're going to disable that line. Let's give it a go. Okay, the code is deployed. We're going to enable it. Here on the shuffleboard, we're going to have the elevator position. I'm going to hit the Y button. It just went up to the 2000 position. The A button brought it back down to the ground. B took it up to the 1000 position, and the X to the 1500 position. If you think about this past year's game, or the year before that, where you're going up and down, I think it was not this year's game, but last year's game, where you're placing the ball up and down. You just set these values to wherever you want the elevator to go to drop the ball in the goal. And this is all you have to do. You don't have to manually drive the machine up and down. You just hit the button. As long as you know what these values have to be to line it up with the goal, you're all good. Not only that, the PID loop is taking care of managing the elevator, and the Talon SRX with the breakout board has automatic limit switches in it, so you don't have to worry about that either. It's that easy. For this exercise, I used a little $20 motor. It's not FRC legal, but it has an encoder on it, and it's the one I used in the previous picture.